So before I talk about domain and range, I need to show you interval notation first. So interval notation is a way that we write, it's a more sophisticated way that we write an interval of numbers. You are probably used to seeing it look something like, if I have a number line, let's say I wanted to describe that. How would you describe that? Greater than or equal to 2. X is greater than or equal to 2, right? Y'all remember doing that? And maybe I have one that is between two things. Let's say -3 and 10. This one's got an open, this one's got a closed. How would you describe that? X.
X 10. Oh, X greater than what? Oh, yeah.
Because it's between, it's sandwiched between these two numbers, right? So when it's open, it's not inclusive. That's exactly right. So it doesn't get the little line under it. It gets the little line under, meaning it includes that number or it's filled in. Okay. First thing we're going to change is we are going to change the greater than and less than signs to brackets or parentheses. So if it is included or inclusive, I'm going to use a bracket that opens the directions that the numbers go. So greater than would open to the right here, okay? It's a bracket. If it's closed, what I'm going to do is use a parenthesis. I would have a bracket here. Now, we're not going to use the number line right now. I'm just showing you how it's going to correspond. Because this goes off forever and ever and ever this way, I'm going to be a little more sophisticated with how I describe that. And I'm going to describe that direction as positive infinity. Have y'all seen the infinity sign before?
Yeah.
Okay. So then to the left, I would describe as negative infinity. So if I were to write this inequality, x is greater than or equal to 2, using interval notation, I would say bracket, meaning include this number, start at 2, and keep going until you get to positive infinity. And I'm going to put a parenthesis because infinity is all, you can't be infinity, right? That's kind of a conceptual thing. So you always put a parenthesis. Parenthesis means non-inclusive, so it does not include that value. And since infinity is not an actual value, it's like conceptual, we would put a parenthesis. But the 2, we included, it's a filled-in dot, or it's underlined, it's or equal to. That means I need a bracket. So you just have to remember bracket included, parenthesis not inclusive. So this one would start with a parenthesis at -3 and keep going until I get to what? 10, and it includes 10, so it's a bracket. So this is saying all numbers between -3 and 10, including 10. That's okay. It's all right. Look, it's fine. It's good. No, it's okay. Let me give you a little chart like this and see if it helps. If I had less than, then I would use a parenthesis. Actually, it's got to go the other way. I'm sorry. Greater than would be a parenthesis this way. If I have less than or equal to, I'm going to have a bracket, and if I have greater than or equal to, I'm going to have a bracket. So these would be my open dots going, let's see, that's greater than going to the right. This would be open dot going to the left. This would be closed dot going. These are all different ways of really saying the same thing, just writing it a different way. Yes.
Is that supposed to be a greater than sign?
Yes, thank you. My apologies. So let me give you a set of numbers and see if you can write that set in interval notation. Okay? Yeah, sure. I wanted to say that x was less than 2. The key with interval notation is also that you always start with the smallest value and go up. So it's got to go smallest to biggest. So what's the smallest value that x can ever be?
1. Infinity.
Negative infinity. Because it's less than 2. So I'm going to start with negative infinity. And I'm going to put a parenthesis on it because infinities cannot be brackets. Okay? It's not correct. Correct. It's not bounded to the left. So negative infinity up until what? 2. Does that get a bracket or a parenthesis? Parenthesis.
Right.
Bracket includes, so if it was this.
Oh, okay. I see it now.
See the difference?
Yeah.
Okay.
It looks like when we said bracket, you almost drew a bracket.
Where?
That one kind of does look like a bracket.
Look,
This one?
you were
I
going to
mean,
draw a
it's
parenthesis and we were about to say bracket. You
Does
almost
not
drew a
look like a
bracket.
sign.
We kind of screwed that one
I'll be careful too.
up. It doesn't look like it would.
So if it includes, so like this line is under it, that's how you know to do a bracket. If it does not, it's a parenthesis. And infinities always get parentheses. Let's do another, because I got to add a little something to it, but I want to make sure you got this. Write that in interval notation. All right. No. There can be, but not here. No. I'll show you multiple parts. What's the smallest value x can be? 0. Not this time, because this time it's sandwiched between 2 values. Do you see that? So, right. So 0 is the smallest. Does it get a bracket or a parenthesis? Why? Not included, there's no line. It goes up to
4.
Y'all have got me so self-conscious about brackets and parentheses. Okay. 4, does it get a bracket or a parenthesis? A bracket. So that's it. It's just writing it a different way.
So we don't do anything.
No, this is just, we're going to use it to describe sets of numbers. We're going to use it for domain and range on the graph we did last night. Yes, it's exactly, that's domain.
That's describing it.
Right, yes. Okay, let me add one little piece to this because I would be remiss if I didn't, since you have to do it not tonight but later, so I need to make sure you can decipher. If you think back whenever you learned about inequalities, you learned about compound inequalities, and this is a compound inequality, it's an and, right? X is greater than 0 and less than or equal to 4. There's another kind. Do you remember what the other kind was? There's 2 kinds of compound inequalities. There's an and that sandwiches between 2 numbers, or. And I always call those chicken wings because they look like chicken wings off to the side. Okay. it looks on a number line, it'll look something like this. It's probably the way I draw it too.
Yeah,
Makes me
just
think
way
of
you
that.
draw it.
So this is saying that x is less than or equal to 0, or x is greater than 5. Okay? So if you think about how we've been writing this interval notation, I can't put from 0 to 5 because there's nothing between there. So I'm going to have to write two different inequalities for this and join them together. Okay? Did y'all learn about, and I'm amazed that everybody says every year they have it, I keep having somebody come through, about union and intersection of sets?
Of sets?
No.
Like sets of numbers? No. So, then we'll just not go into that. We'll just put a U in between to combine two sets of numbers, okay? So, let's look at the left side first. If I asked you to describe the left side in interval notation, tell me what you would do. What's the smallest x can be? Negative infinity with a parenthesis up to what?
0.
To 0. Does 0 get a bracket? Oh, yes.
So if it's shaded, it's or equal to.
Yes. That is correct. Now, because there's another piece over here I need to hook with this, and I don't have more than two terms inside my parentheses and brackets, I'm going to hook it with a U that says also included in this set of numbers. What's the next smallest thing x can be?
5.
5. With a parenthesis up to
Infinity.
Positive. I swear.
because my pen slipped.
No, I'm talking about because we're writing like a line, a sideways 8, a 0 with half a box around, a U in between.
Welcome to hieroglyphics. No, I'm just kidding. It looks normal to me.
Was even a math teacher for him?
A lot.
Just graduated college.
This is just my second year teaching, right? I'm just kidding. 12 to answer your question.
Can you show this to an English teacher? I wonder what they would.
All the numbers in the world, all the real numbers, but I want to leave out the number 2.
Okay.
I want to describe all the numbers in the real number system, but I want to leave out the number 2.
Infinity
Everything
without
below
2.
2 and
How?
everything above 2.
Exactly right. Everything below 2
Everything above 2.
and everything above 2. So how can I express that?
So negative infinity.
Using all these symbols. Do it. Okay, so start it. Negative infinity.
We'll just parentheses. 2, yeah. And then U, and then 2,
Positive.
and then positive.
That says I want everything except 2. Get as close as you can to get to 2, but don't include it. Then start as close as you can to 2 and go up forever. What if I want to describe all the numbers?
Infinity.
Negative infinity to positive infinity. This will probably be the most common as you describe range here in the beginning.
So that's not that hard.
Okay.
Don't say that.
think
Now it's got to get
What?
harder.
Have I done?
Right.
Because now you
Don't.
have to do
No, I'm just kidding. It's not hard. It's not hard. Okay, so we're going to use this to describe the domain and range. So this is the form you're going to write the domain and range in. So now I need to tell you about domain and range. I hope you know about domain and range a little bit.
The rank.
The range is easy. I remember learning about it, but I don't remember.
I don't remember.
Range is the distance between two numbers.
Oh, no.
The range is like the distance between greatest and like small numbers.
Okay, so you're talking about the range of a set of numbers. I'm talking about the range of a graph.
You can do that?
Yeah.
So guess
Sorry.
you didn't learn that.
Okay, domain of a graph describes all the x values of that graph.
Oh.
Okay, everything that x can be is the domain.
Yeah, range.
The range. Yeah.
And so that means range. I think you did.
You did.
But it was probably very basic. It was probably something like, I'm going to give you a T-chart.
Yeah, that was.
There it is.
What's the range of that relation?
2. What's 2?
2, 4, and 6.
Oh, yeah, 2, 4, 6, and then 1, 2.
And then the domain would be, because that's not an actual equation that I'm graphing. Now, if I gave you the equation of the line and asked you for the domain and range, it would be fairly different. But I'm just giving you a set of values asking for the domain and range. Okay. Let's say, however, I gave you a graph. Oh. We'll start easy. Let's start with the line. Green line. The line is green. That's just the axis. What is the domain of the green line? In other words, what all values can x be? You're absolutely right. An infinite number.
Oh.
Are there any restrictions as you look left to right?
No.
No. I could use any, I could put in -1,000,000 and still get a corresponding y value back out for it, right? There's nothing keeping it bounded. So my domain for that would be -infinity to infinity. Maybe you described it, if you've done it before, as all real numbers.
Yeah.
Okay. Some teachers might do x is a member of the real number set. Have you ever seen it like that? Maybe you just wrote out x, all real numbers, x is all real numbers or something.
Yeah, I think that's what
Okay.
I put all real numbers.
We're going to be more sophisticated than that. So now the range, do the same visually with the range. Just look at it. No restrictions. So it's the same thing. So let me give you one with some restrictions. It wouldn't be fun if I didn't give you some restrictions. Make you think a little bit.
You get joy out of our torture.
This isn't torture. This is fun.
This is on video.
Let's say I have, this is the point 0, 3, and it is also going to be the vertex of my parabola that is going down. Did somebody say my what? It is not a parabola. Oh my goodness, goodness. Okay. How are you going to call it a parabola on your exam? You going to write P-A-I-R?
No, like.
Don't you spell it the same way? Parabola.
Oh, you would say parabola.
Parabola.
It's a parabola.
I know.
Domain describes x. X is the horizontal axis, yes. Left to right. Are there any restrictions? In other words, is there any time that you could put in a value for x and you would not get a value back for y?
No.
Right? Look left to, that's okay. Left to right. If you think about the way a parabola does, even though it starts to go down really fast, it's still inching outwards, right? It's still getting wider as you go down further. So my domain, take a guess.
Is negative infinity.
All real numbers which we write.
Negative infinity. Then positive.
Now comes the hard part. All of your parabolas, by the way, the domain is going to be -infinity to infinity.
Cool.
But I wanted to show you what it looks like. What one, I'll show you in a minute what one looks like it doesn't. But I want you to be able to think it through because we're going to graph lots of stuff in here. It's not always -infinity to infinity. There are. We're going to graph cubics and quartics and all types of fun stuff. Cubics and quartics.
Sounds like you did that.
All right, range.
That has a restriction.
That does have a restriction. Where is that restriction? It can't go above 3. We see that, right?
Right.
So once I can think that through in my head, now I can think, how do I describe like this? It can't go above 3.
Negative infinity.
Y'all are so smart. Oh my gosh! This is the first time I've had a class get that the first time. Why do you need a bracket?
Because this is not, and you're on it.
You're on it. It's a point there. I can be 3, so I do a. Give yourselves a pat on the back. Way to go. Okay, that's okay. We're good. If you're still confused, we're gonna do some more. Okay.
Bless you.
Bless you. All right, let me give you another parabola. And I want you to think through this one. This one, my vertex is going to be at 2, -3, and it's going to go up. Try this one on your own. Domain and then range. You're getting there.
Negative infinity.
Yep. What I do now?
Oh, the bracket.
Up to.
Infinity?
Yes.
With, yeah.
Parentheses. How about range? Range describes y. So I want the lowest the graph ever goes. -3 with a bracket. Up to. Give me a thumbs on domain and range. Up, down, sideways. Okay. Just to see.
I don't even know what I don't know.
Just to see. I want to try something with you. Okay. Tell me when you got. This is gonna look terribly awful.
Is it a oval?
It is. It's called an ellipse. Okay.
It's called the what?
An ellipse.
Ellipses.
I want to know the domain and the range of this particular shape, and then I'm gonna give you one more that's even harder. I want to know the domain and range of the whole thing, because you always look at it as a whole. This should be connected here, but it's kind of like. Okay.
Good job, Evan.
What'd you say? It can't be infinity? Why?
Because it's connected.
It's connected. It doesn't go off forever in any direction, so that's absolutely right. So as I look at this, and domain is my x, what values can x have?
4 and -4.
It can go, the smallest x can ever be, this is my x-axis, is -4. Can't ever get any
So
smaller.
write the positive, -4, and then you put a comma.
Not positive -4, but
Negative. I mean, -4.
-4 to +4.
I'm doing right.
Bracket.
Yeah, you're trying to jump the range too. So this tells me that my x values can be anything between -4 and 4 inclusive. Y'all got it?
Mm-hmm.
Okay. How about range?
-2. And then 2 bracket.
It is. Y, okay. This is x, this is y, range does y, so the smallest value that range that y can be, or the lowest point on the graph is -2, up to the highest. Furthest left to furthest right, lowest to highest. Yes, when we start graphing asymptotes, but not yet. Okay. One more, last one, and I'm gonna set you. Yes, you're exactly right. Yes, good job. See? She said, "Is this where the or comes in?" All right, so Domain is easy on this one, and I hope you see that domain is easy on this one. Because left to right,
It'll keep going.
it never stops, right? It keeps going. So what is the domain here?
Negative infinity.
Here's where it gets tricky.
Range?
The range.
Okay, well,
What's the smallest?
Negative
I don't know,
one.
well, which one are we doing?
You gotta look at it as a whole.
Negative. So negative one.
Smallest one? The negative one?
What's the lowest the graph ever gets?
Negative.
Negative infinity.
Oh.
No, negative.
To -1, bracket or parenthesis.
Bracket.
And I want to join that with, so it skips some space. Yes.
3 with
The bracket.
and then
And then
positive.
the
I got about